Welcome to Algebra Final Corrections. Follow along and make all the corrections that you need to. Alright, we'll start off with number 1. Subtract 14 from both sides. X equals negative 19. Okay, number 2. Straight into these absolutes. In order to solve for an absolute, we need to isolate the absolute. So let's add 3 first. 4 times the absolute value of 8n plus 10 equals 56. Divide both sides by 4. Divide by 4. We have 14. So we have 8n plus 10 equals 14. So we have to separate that into 2. We have to separate that into 2. So we have 8n plus 10 equals 14. And we also have 8n plus 10 equals negative 14. N equals 1/2, or 8n equals negative 24. Divide both sides by 8, and I get n equals negative 3. There's my 2 answers. They will both satisfy n for that. Alright, first step, I'm going to distribute. We have 15x plus 10 equals negative 6x minus 11. So let's add 6x to both sides. I like to keep my x's positive. Minus 10 on both sides, I get 21x equals negative 21. Divide both sides by 21. I get x equals negative 1. Alright, 10 more than y. So 10 more than y is greater than or equal to 17. Solve the inequality and then graph the solution. So we have, I'm going to distribute this negative 3. So we have negative 3 is less than or equal to negative 3 plus 3x. So I'm going to add 3 to both sides, and I get 0 less than or equal to 3x. Divide by 3, divide by 3. So I get 0 divided by 3 is 0. It's less than or equal to x. So x is greater than or equal to 0. So I have my circle, and I fill it in because it's equal to. There it is. Okay. Write the inequality that's represented by the graph below. So I see that x is less than or equal to 0. So x is less than or equal to 0. And x is greater than or equal to 4. 0 is greater than or equal to x. So x is less than or equal to 0. X is less than or equal to 0. X is greater than or equal to 4. X is greater than or equal to 4. Alright. Pause the video when you need to make necessary corrections. Number 7, determine whether the relation is a function. If the relation is a function, determine whether the function is linear or nonlinear. So let's check. So the difference from negative 3 to 0 is plus 3. It's plus 3, plus 3, plus 3. So we have a consistent change in x's. Minus 1, minus 1, minus 1, minus 1. So we have a consistent change here. Also check to make sure there's only one y value for each x value. So yes, it's a function. and it is a linear function. Alright, to write an equation in slope-intercept form of the line with the given characteristics. So slope-intercept form is here, but we have a slope and a point. So what we want to do, what would be easiest is to start it in point-intercept form, which we have right here. Point-slope form. So y minus y1, so y minus 1 equals the slope, which is m, times x minus x1. So y minus 1 equals 2 times x plus 3, because negative and negative equals positive. So y minus 1 equals, and now I'm going to distribute the 2. So I have 2x plus 6. Now I add 1. Y equals 2x plus 7. Write the equation in slope-intercept form for the line with those characteristics. Write an equation in point-slope form of the line with the given characteristics. So it goes through 0.44, and it's parallel to this one. So the slope equals negative 1/2, because it's parallel, so it will have the same slope. So y minus y1, y minus 4 equals negative 1/2 times x minus 4. Write an equation in point-slope form. There's point-slope form. Alright. Find the length of BW. So I have 31 minus 8. So it'll be 23. So BW equals 20. BW equals 23. Okay. J is negative 3, 7. K is 4, negative 2. They're the endpoints of the line, so I'm going to find the coordinates of the midpoint. And I gave you the midpoint formula, so I have negative 3 plus 4 over 2. 7 plus a negative 2 over 2. So negative 3 plus 4, that'll be 1 over 2. 7 plus a negative 2, that's 7 minus 2, that'll be 5 over 2. So you got 1/2 and 5/2, or you could rewrite it as 0.5 and 2.5. Either way is correct. Alright, negative 3, 7, and 4, negative 2 are the endpoints of the line segment. Find the distance. So I give you distance formula right here. So let's go. Negative 3 minus 4 squared plus 7 minus negative 2 squared. So I have negative 7 squared plus 9 squared. So I have 49 plus 81 130 square rooted is 11.4. Let's just double check. I've got my negative 3 minus 4. I've got my 7 plus 2. Okay, there it is. So it could either be square root of 130 or 11.4. Alright, next one. Number 13, solve the system of linear equations. So we have two variables in here. So what I'm going to do is I'm going to subtract these. So I need to add the opposite. So negative, positive, positive. So that becomes 0. And I get 7y equals 21. 7y equals 21. Divide by 7. So we get y equals 3. Now I need to find out what my x value is, so I'm going to plug my y in for here. So I get 2x plus 6 times 3 equals 14. 2x plus 18 equals 14. Minus 18. 2x equals negative 4. Divide by 2. X equals negative 2. So now what I want to do is I want to check. So I'm going to take my original equation, 2x plus 6y equals 14. And I'm going to plug these in. So 2 times negative 2 plus 6 times 3 equals 14. So negative 4 plus 18 equals 14. Negative 4 plus 18 is 14 equals 14. Checks out. Alright, now for these two, I still have two variables in each, but what I'm going to do is I'm going to use substitution. So I'm actually going to substitute. So x equals this, so wherever there's an x in this equation, I'm going to put this. So 4 equals negative 4 times y plus 3 minus 12y. 4 equals negative 4y minus 12 minus 12y. So I'm going to combine my like terms. I have a negative 4y and a negative 12. So 4 equals negative 16y minus 12. Isolate my variable, so I add 12 on both sides. I get 16 equals negative 16y. I'm going to divide by negative 16. So I get y equals 1. I'm sorry, y equals a negative 1. Now I'm going to plug this back into here. So I have x equals y plus 3. X equals negative 1 plus 3. X equals 2. So if I plug this in, I should get a true statement. So I want to use this second one. 4 equals negative 4x minus 12y. Now I'm going to plug in negative 1 for my y and 2 for my x. So 4, negative 4 times 2 minus 12 times negative 1. 4 equals negative 8. Negative and negative equals a positive. 4 equals negative 8 plus 12. 4 equals 4. That checks out. Alright, now graph y equals 1/2 x minus 1. So I know that my slope is 1 over 2. My y-intercept is negative 1. So over here I find negative 1. That's my y-intercept. And then 1 over 2, I go up 1 over 2. Up 1 over 2. There's my line. Alright, graph this next one. Y equals 3x minus 1. Well, my slope is 3 over 1. It's 3. My y-intercept is negative 1. Y-intercept is the same. And then I go up 3. 1, 2, 3, 1. Somewhere over here. And that's your line. Alright. Last few problems. Graph the system of linear inequalities. So for this first one, I have my slope equals 1 over 1, and my y-intercept equals -2. So I go -2, and then 1, 1, 1, 1. And it says y is greater than. So, oops, sorry, that was a little bit off. It says y is greater than. So, this was off the camera, I'm sorry. My slope for this one is 1 over 1, because that would be a 1. And my y-intercept is -2. Now I got to figure out if I shade in above it or below it. Greater than. I'm going to plug 0, 0 in and see if it makes it true or false. So 0 is greater than 0 minus 2. 0 is greater than or equal to -2. It is in fact greater than. So I shade in this whole part of my graph. Okay. Now for this one, y is less than -x plus 2. I have a slope of -1 over 1. And I have a y-intercept of 2. So I go find my 2, and then I go up 1, positive 1, -1. Or I go -1, positive 1. And this is less than, so this is going to be a dotted line, a dashed line, like that. And then I need to know if I shade in this section or I shade in this section. So less than, I'm going to take 0, 0 again and plug it in. 0 is less than 0 plus 2. 0 is less than 2, so that is in fact where it is. So it's everything greater than this dashed line. So the solution for this is all of this here, where it's both yellow and green. That's your solution. All right, number 18, you didn't have to do. We didn't get that far in the book yet, but we will cover it later. All right. Use a diagram to decide whether the statement is true or false. Point G, C, and E are collinear. So I've got G, C, and E. G, C, E, are they collinear? They most definitely are not. Plane S, this plane, and plane T, this plane, intersect at line L. Well, that's where this plane and this plane, that is true. Points A, D, and C lie in plane S. So A, D, C, are they in this plane? They are, in fact, in that plane. Ray CG, and ray FE are not opposite rays. That's true. We do not know if those lines are parallel, and they're not part of the same line. Point B lies on plane S and plane T. Point B does not lie on plane S. So that is false. All right, make sure you take pictures of all your corrections. Hand those in to me. And nice work with your Algebra 1.